This is a continuation of Lesson 2, Section 1.6, dealing with rational expressions. And we're going to be looking at division, addition, and subtraction. With division, one of the first things we do is, if you remember how you deal with fractions, is we actually change the division problem to a multiplication problem. We basically multiply by the reciprocal. To find the reciprocal, you basically flip the second fraction over so that the top goes to the bottom and the bottom goes to the top. So the first thing I'm going to do is rewrite this problem as a multiplication problem. So I would have 6p squared plus p minus 12 over 8p squared plus 18p plus 9, and it's going to change to times, and 2p squared plus 11p minus 6, which was the original denominator, now becomes the numerator, so that the bottom goes to the top, and then the denominator is 6p squared minus 11p plus 4. Okay, so now that I've rewritten it, I can treat it like a multiplication problem, which requires that I factor all of those polynomials. So that's what I'm going to do next. And again, you may need to use some scratch paper. Okay, so let's see. I want to do, how about if we do 2p and 3p, and I can do 4 times 3, and this would be plus and this would be minus. I'm doing trial and error. Okay, in the denominator, let's try 4p and 2p, and to get 18, I could do 3 and 3, and they're both positive. Then in the second numerator, I would have, let's see, 2p and p, and 6 and 1, so minus. Let's see, let's try 2p and 3p, and I want to add to get 11. So, 4 and 6 does not add to 11. 8 and 1 do. Okay, so there we go. Took me a minute to factor them. Trial and error sometimes takes a little bit of time. And then we're going to simplify on the bow tie. Okay, I'm going to rewrite it again real quick. 2p plus 3 and 3p minus 4 over 4p plus 3 and 2p plus 3 times 2p minus 1 over p plus 6 over 2p minus 1 over 3p minus 4. And then we're going to simplify on the bow tie. Okay, so diagonally, I have a 3p minus 4 unit that can be divided out. On the other diagonal, I have nothing. On the vertical, I have 2p plus 3. And on the other vertical, I have 2p minus 1. So when I have everything divided out, I'm left with p plus 6 over 4p plus 3. So the division is very much like multiplication. But you have to remember to flip the fraction or flip the dividend or the second rational expression before you do the multiplication. Now, addition and subtraction is a whole new ballgame, because we know with fractions, when you're dealing with fractions like, say, 2/3 plus 1/2, in order to add those, we have to have a common denominator. And one of the things that most students do to find a common denominator is simply multiply the two numbers together. So you guys will probably say 3 times 2 is 6, and you're going to say, okay, that's my common denominator, and rewrite the fractions with 6. Well, 3 goes into 6 2 times, and 2 times 2 is 4. And 2 goes into 6 3 times, and 1 times 3 is 3, so that we ultimately get 7/6. Well, that same concept applies to rational expressions. It's just it's not as nice looking because we have a polynomial like y minus 2 or y plus 1 in the denominator. But since those are two different pieces and both fractions need both pieces, that is kind of my clue that my common denominator here is going to be y minus 2 times y plus 1 for both of the fractions. So I'm going to get it set up. Okay, plus y minus 2, y plus 1. Now, the numerators that are already present are going to remain. Okay? Can't just get rid of them because you want to. Okay, so then we have to think about it. In the first fraction, I already have the y minus 2. So I need to multiply by the y plus 1. In the second fraction, I already have y plus 1, so I'm going to multiply by y minus 2. In a sense, you're basically multiplying by 1, okay, in order to add the piece that you have that's missing. So if I put all this over the same, I have the common denominator, so we're going to keep that denominator of y minus 2, y plus 1, and we're going to have y plus 3 times y plus 1 added to y minus 3 times y minus 2. Now, I'm not finished because I need to actually simplify that as much as possible. And so the first thing I need to do in order to simplify that is to multiply those things together in the numerator. So I'm going to do this piece first. I'm going to use full. So I have y squared plus 1y plus 3y plus 3 added, and I'm going to come back and I need to multiply together the other two pieces. So I'm going to do y squared minus 2y minus 3y plus 6. Now that's all still over that same common denominator of y minus 2, y plus 1. Still not home free yet because now I need to combine like terms in the numerator. So I have y squared plus y squared is 2y squared. 1 plus 3 minus 2 minus 3. 1 plus 3 is 4. Minus 2 is 2. Minus 3 is minus y. And then I have plus 3 plus 6, which is plus 9, over that common denominator of y plus 1, y minus 2. Sorry, I changed the order there. It's okay. All right, then, again, you may think, well, okay, I'm done now because I've got it all added together. But remember, we always want to try to simplify our fractions. So I need to try to think, does this particular polynomial 2y squared minus y plus 9 factor? And I don't know if it does or not off the top of my head, so I'm going to kind of go over here and maybe try a little bit of trial and error. I could do 6 and 3. That doesn't work. 2 and 9. That doesn't work. So it doesn't appear that this factors. And so since it doesn't factor, there's nothing else to simplify out. So your final answer is 2y squared minus y plus 9 all over that common denominator of y plus 1, y minus 2. All right. Then we have a subtraction problem, but it's the same process. In order to do the subtraction, you need to have a common denominator. So here again, let's think about this. I have, in the first fraction, I have x minus 1 over x plus 1. And in the second one, I have 2x plus 3 over 2x plus 1, but I need to have that common denominator, which means both fractions need both pieces. So if I add the 2x plus 1 to the denominator, I have to also add it to the numerator. If I add x plus 1 to the denominator of the second one, I have to also add it to the numerator, so that I end up with a common denominator, which is my goal. Once I have that common denominator of x plus 1 times 2x plus 1, I keep it, and then I have in the numerator x minus 1 times 2x plus 1 minus, watch the minus sign, 2x plus 3 times x plus 1. I do have to try to simplify that. Just like with fractions, you always want to simplify. So in order to do that, I'm going to multiply these polynomials together, and I'm going to do x minus 1 and 2x plus 1 first, again using the FOIL technique. So I have 2x squared plus 1x minus 2x minus 1. And then I have the minus sign. Okay, so I got to be extra careful here. I got this minus sign. And then I need to do that second multiplication. And then I'll worry about the fact that it's subtraction. So I'm going to FOIL these second two pieces together. So I have 2x squared plus 2x plus 3x plus 3. And I still have my common denominator of x plus 1, 2x plus 1. So I'm going to keep that common denominator, but then I need to combine the like terms in the numerator. And I want to show you how I'm going to distribute that negative, because this is one of the areas where students make a lot of mistakes, is they don't distribute. Remember, there's an understood 1 here, so we got to distribute it all the way through. So I would have 2x squared plus 1x minus 2x minus 1 minus 2x squared, minus 1 times 2x squared, minus 1 times 2x is minus 2x, minus 1 times 3x is minus 3x, and minus 1 times plus 3 is minus 3. And then finally, I'm going to come back and combine the like terms, okay, together. So I would have 2x squared minus 2x squared, that's zeros out. I have 1 minus 2, which is minus 1. Minus 2 is negative 3. Minus 3 is negative 6x. Okay, so I've done the x's. And then I have minus 1 minus 3, which is minus 4, over our common denominator of x plus 1, 2x plus 1. Now I do notice in my numerator that I have a common factor of negative 2, which would leave me with 3x plus 2 over the x plus 1 and 2x plus 1 in the denominator. Now either is acceptable. Factoring it didn't really help me in terms of simplifying. There's nothing to divide out, but I've checked it to be sure that I don't have anything.